Let's look at some very interesting and important aspects of facial animation, which is the animation of the eyes. There's two parts to that. One is the animation of the eyes themselves, and the other is the animation of the eyelids. And there's actually a multi-layered approach to get all of that working. It's actually a rather complex setup of constraints making it work. We're not using shape keys for animating the eyes. I'm using rather direct bone driving. And the reason for this is that, as you can see quite clearly here, everything here is rotating around the eyeball's central center point. And rotation is not achievable via shape keys. You can do it with multiple shape keys blended on top of each other, but the result isn't quite satisfying and is very complicated to get. To do rotation, you really need bones. And so that's what we're using for the eyelids and the eyeballs. Now, as well as having this general tracker, which you can see the eyes track it left to right, when it goes up and down, the eyelids also have to track somewhat to make that effect work. And you also have these controllers here, which you can scale down to close the eyelids, and you can also move them up and down to sort of change the attitude of the eyelids while keeping the size of the eyelid the same. There's a shape key driving bone, one left actually, that just open and closes the pupils. So you can have Mankind's pupils dilate or contract depending on the amount of light, for instance, or whether he's happy to see someone, or so on and so forth. So let's first look at how this control works, getting the eyelids to become smaller and bigger, and how it allows them to change their attitude. Now, the actual facial controls for this group are on layer 9, but if you click on the third layer from the right, and the last layer, I think that's layer 16 and layer 14 or so, you'll see that there are further bones. The bones here directly bind geometry, the eyes and the eyelids, while the bones here are helper bones. And you need the combination of controls, helpers, and geometry bones to get everything to work right. So let's have a look at what's happening with the eyelids. And to see things more clearly, I'm going to go into octahedron mode, because you'll see that there are some bones lying on top of each other. This bone here is the eye bone, I.L, and this bone here is the eye base.L, and it is the parent of both of these eyelid bones, this one and this one. Now, the eyelid top and bottom bones are actually deforming the eyelid geometry, pulling it down or up with it, and they're each of them tracking this small bone here that's a child of this bone. So when you scale this bone, those two bones go closer together, and the eyelids just track them with a lock track constraint up and down. And also moving them now illustrates how that works. So that's actually a pretty simple set of constraints, so you can get only one controller to control the eyelid. And you have a quite similar setup on the other side. The tracking is a little bit more complicated, and it's done by via a series of action constraints. Now, the reason we use action constraints here instead of any other kind of constraint, like a track constraint, is because you want the eyeball to track the target, but only so far. If the target goes above the head, you wouldn't want the eyelids to flip inside out, for instance. The action constraint is done by creating an action, first of all, and you can see the name of the action is up-down eye track. So we create an action, which is sorry, up down eye track is the name of the bone. The action is here, MC driven eye up down EUD. So if I select that and scrub through it, you'll notice that it's a 3-frame action, and it has the eyes in the top, in the bottom, and the middle. And it affects both the eye and the eyelid. And because it's a driven action, it's being driven via the location of this. So you notice the eyes only go down so far and up so far. They don't roll up into the head. Now let's look at how those action is driven on the eyelids, for instance. They're driven the same way on the eyes themselves. You'll see that they have local depressed, and that they're looking at the bone up-down eye track here, and you can find that just by selecting the constraint target. So this is up-down eye track, which has a lock track constraint looking at this target as it goes up and down. And so that's fairly simple. Now the reason I did it this way with a lock track is so I could get a rotation around x-axes. In Blender 2.44 and also Blender 2.45, the most reliable way to drive an action constraint is using the x-axis rotation of a bone. The reason for that is that the order of calculation of rotations is XYZ in Blender, so the x-axis rotation is always the correct one. And so when you have a complex motion that's up, down, left, right, I use a lock track constraint that we have on this to break it down into an up, down axis on the x rotation of a bone. And that helps me keep things a little bit simpler. And so that's simplifying my job a lot when I'm using these constraint drivers. And so I'm using the up-down eye track, and I'm using its x rotation. And the rotation angles for action drivers in 2.44 and 2.45 are offset from the actual rotations of the bone. And I'm afraid the only way of finding the actual number to use here is experimenting when you're adding the constraint via trial and error. And the 0 in this case is 100 instead of just simple 0. And you see that the frame 2 is the 0 frame when it's in the middle. Now, once you've done that experimentation, it becomes pretty easy to apply that action constraint. And note that this offset isn't always there. It really depends on the setup of the rig. I do know that the versions of Blender after 2.45 have a revamped constraint system which do not have this particular wrinkle in creating an action constraint, and indeed in those cases in future versions of Blender you'll be able to drive on things like location and scale directly rather than having to depend on rotation. But this version of ManCandy was designed for Blender 2.44, so it's using 2.44 style constraints. And so that is it for the eyelids. They just go up and down. The actual eyeball has a more complex set of constraints. It also has the up and down tracking constraints in much the same way as the eyeballs, but it also has a lock track on the left eye target, so it can go left to right. And you'll notice that we have this eye track here, and it has a child here, and this eye target, which is copy locationing to it here. And it's kind of nice to have things set up this way for the left and right, because I can scale this bone and have both tracking balls go in and out. So it can cause ManCandy to squint. Or is that squinting? Maybe that's not squinting exactly, but it's, you know, this thing that happens when the eyes look at Oh, he gets cross-eyed. That's what it is. He gets cross-eyed. And if we look on the right side, for instance, for the eye tracking, where I'm just copying the rotation of the eyelids on the left side, so it's much simpler. And for the eye itself, I'm copying the rotation of the left eye, but then I'm adding the lock track on top of that so that I can do the squinting. So the constraint setup on the right is slightly simpler than the constraint setup on the left. And that's really how you set up the eyes in ManCandy. Now you could also drive correction shapes, but I found that I didn't need that with ManCandy's mesh.